Stretching the graph of f of x equals sine x vertically away from the x-axis is given by g of x equals a times sine x provided that a is greater than 1. Sine x stretches away from the x-axis by a factor of a. Consider f of x equals sine x, here in red, and one of its transformations. In blue, g of x equals 2 sine x. The graph g of x is the result when f of x stretches away from the x-axis by a factor of 2. Shrinking the graph of cosine x vertically towards the x-axis is given by h of x equals a times cosine x provided that a is between 0 and 1. Cosine x shrinks towards the x-axis by a factor of a. Consider f of x equals cosine x and one of its transformations, h of x equals 0.5 cosine x. The graph h of x is the result when cosine x shrinks toward the x-axis by a factor of 0.5. Let f of x equal sine x. Its graph is displayed below. The functions g and h are given by g of x equals 3 sine x and h of x equals 0.25 sine x. Carefully sketch the graph of g of x on the grid below. Label a maximum point on the graph of g. Carefully sketch the graph of h of x on the grid below. Label a maximum point on the graph of h. Alright, so here, let's just pick a random point. So this point right here at pi over 2, the sine of pi over 2 is 1. So if we have x is pi over 2, sine of pi over 2 is 1. But now for g of x, we're going to multiply that 1 times 3. So this point moves up to there. The zeros stay where they are, because if sine of 0 is 0, 3 times 0 is still 0. But this point, for example, 3 pi over 2, the sine of 3 pi over 2 is negative 1. So this whole thing here is negative 1, times 3 is negative 3. So this is what g of x is going to look like. It's a more exaggerated version of a sine wave. The maximums are higher, the minimums are lower. The opposite is true for h of x. So for example, the zeros are still going to be, this point is supposed to go right through there. Okay. For h of x, the zeros remain where they are at the exact same points. The sine of pi over 2 is 1. But 0.25 times 1 is 0.25. So this point is going to move down to there. The minimum is going to move from negative 1 to negative 0.25. H of x looks like a very mild version of a sine wave, not as extreme, less extreme than a sine wave. So there is g of x and h of x. And here are much nicer versions of the graphs. Let's consider the function given by f of x equals a times sine x plus k. The midline is at y equals k. That's the horizontal line that is midway between the high and low points. The amplitude a of a sinusoidal wave is half the wave height. This makes the wave height equal to 2a. So the amplitude goes from here up to there. So from the midline to the maximum or from the midline down to the minimum. The maximum value of a sine or cosine function is k plus a, because k is this line here. You add a, you'll get to that maximum. The minimum value of a sine or cosine function is k minus a. So if you begin at k and then you subtract a, you get down to the minimum. The graphs of the functions sine x and cosine x complete one cycle on the interval from x greater than or equal to 0 and less than or equal to 2 pi. Of course, starting a cycle at x equals 0 and ending at x equals 2 pi is arbitrary. Slide the rectangles left and right. One cycle of the sine wave is enclosed by each of the dashed rectangles. So we can move these. We can start our intervals anywhere. They don't have to start right at 0 and end at 2 pi. You can start it at pi over 2 and end it at 5 pi over 2. What are the left and right boundaries of the dashed rectangles? Compare and contrast the sections of the curve in each rectangle. The period of sine x and cosine x is 2 pi. In the figure below, the period is one cycle and is enclosed by each of the dashed rectangles. Are the blue and green curves congruent? Discuss. The curve sine x for x belonging to the interval L to L plus 2 pi is congruent to the curve sine x for x belonging to the interval L plus 2 pi to L plus 4 pi. A period of sine x and cosine x is any multiple of 2 pi. The functions sine x and cosine x repeat every absolute value 2 pi k for integer values of k. This means that sine x equals sine of x plus 2 pi k, and cosine x equals cosine of x plus 2 pi k. The period of sine x and cosine x is 2 pi. The period is the smallest period and represents one cycle. True or false? Sine of 1 equals sine of 1 plus 2 pi. This is true. Any sine value where you add 2 pi is going to be the same. Here, however, we have 21 pi, and it doesn't matter if it's plus or minus because you can go around clockwise around the unit circle or counterclockwise, but 21 is an odd number, so this is false. 9 is also an odd number, so this one is false. Here, cosine 9 pi over 15 equals cosine 9 pi over 15 minus 80 pi. This is true. 80 is an even number. 80 pi is a multiple of 2 pi, so this is true. A good way to think about this is to picture the unit circle, and if we have a point on it, say there, we'll call that x. If you go 2 pi around the circle, you end up at exactly where you started. So you can do that a bunch of times. So for example, you could do it 10 times. You could go around the circle 10 times, and each time you go around the circle, you've gone 2 pi. So 10 times would be 20 pi. Or you could go minus 20 pi, you go the other way, and you'd still end up at exactly the same point. However, if you went around 21 times, you would end up over here, and the sine value would be different. So 2 pi, or any multiple of 2 pi, an even number, you're going to end up at the exact same place. Whereas an odd number, you will end up in the opposite, across the circle, and you will not end up with the same sine value or cosine value.